Hello to everyone, this is Vishal, and today we start some important topic that is Android app architecture. That's what's going on in a Kotlin nowadays, and how you build your application. And there are many things, but in this sequence, we need to discuss about some important components inside that. Without those important components, we never work on that. So as in a Java, I already described how the clean architecture works and how we can implementation. But there is a need to discuss about what is the flow of complete app architectures and how we can implement this clean architecture in a Kotlin also, and how you build your app with less code and lot of stuffs. But we need to discuss some important topics in behind the scene. That means whatever be the work on the small functionalities, as we discussed in my previous sessions, how we can use the high order functionalities, that's lambda, and these be the important things which be work on your coding part. So as in this scenario, we have to discuss about the app architecture. We have how we can use that these things be here in. We have to work with your SOC, and how we can work with layers and VPN approaches, and a lot of stuffs be there. We have to work, but the most important thing is whenever you work with this kind of stuffs, that's how we can use that flow in a data layers. So I don't want to describe these things in data layer or whatever be the design layer. We discuss it on our next part, but we have to go for that is the most important part, the basic functionality that is important whenever you work it, that is called your coroutines, and how we can implement a suspend. So as we have worked with the RX Java in many projects and retrofit, but at this time we'll discuss about the new architecture and lot of new things be here. So we discuss about the flow and coroutines and how we can implement suspend. So that means that's also be a very good instead of using your RX Java, you can implement on those, because of an RX Java or RX Kotlin I already give or provide you the lectures on that, and in the future I will describe you the more about that. But I think 8 to 10 lectures I already prepared on my sessions, so you can check them and just get information about that these sessions. But here today we discuss about the flow and how we can implement that flow, how we can implement the suspend. So before any app architecture, we have to start that this is small topics of the day. And on the next session, I will describe you this app architecture design, how we can separate the layers, how we can implement the clean architecture and a small app beyond that. As I told you, that is many times whenever I get a time, I will make a small sessions or a small project on your clean architecture in a Kotlin, so you can learn a lot of things on that. So first today we discuss about how we can use that suspend, and how we can use the coroutines, and what is the use of the flow in this area, and how we can implement our coroutines in backend resources just like your retrofit, and how we can implement this kind of functionalities, and background processes, how we can make it easy using the flow also. Because of RX Java I already described, in which we can use that the background processes. That means but sometimes that means we have to control over, if we don't go give the complete control over your RX Java, that's I already described in the drawbacks. So on that area or RX Kotlin area, how we can implement these things, this is stuffs on that. So let's discuss about the coroutine, and then we continue this session on the next one, in which we have to discuss about the new app architecture, app designs in the Kotlin, and then layers about that, and also we can implement a functionality on the small project on that. So that means we can get together all these stuffs, but the basic functionality we have to discuss that I separate out at this time, that is the coroutine. So first we have to understand this. What is that exactly? Okay, so if we discuss about the coroutines, so as the name be coroutines, it means corporation and routines means function. So in a simple word, that we can say that when functions cooperate with each other, we call it coroutine. Means there be the many functions and then all functions get work with each other, or that's because your coroutine functionalities. So we can say that it is a concurrency design pattern that you can use in Android to simplify code that executes your asynchronously. Means whenever you work with long data, that means a lot of loading part or any this kind of functionality, or a big images we downloading. So on that cases we can use that coroutine, just like a play. I mean, if you downloaded something in MP3s, or you can downloaded a big data for your recycler view. So a lot of stuffs you can manage it is in an easily way. So that is called your coroutines. And then Android coroutines helps to manage the long running task that might otherwise block the main thread and causes your app to become unresponsive. So that means in my RX Java discussion, I already describes how you can make them asynchronous calls be easily on that cases. So the same thing be here. Over 50% of the professional developers who use the coroutines have reported seeing increasing productivity. So that means most of the functionalities, whenever you work with this kind of coroutines on your day, if they apply on this, so that means they can say that their app process, or we can say the app response be very good. So that means you can use it, and you can that means it is a key of increasing your productivity. So actually whenever I have seen that whenever you work with the Kotlin or Android projects, they just copy paste things from here and from there, and then they don't know about that what is the memory leaking, what be the drawbacks, and which kind of architectures be going good. Mainly work on your activities, all the functionality they're doing in activities. I already given the lectures on your clean architecture in MVVM approaches. That means whenever you work with your any project, any small or a big project, you do that functionalities in a separate way, in a good approaches. But don't do like that. If you create your logics, you make them separate. Do not work with your views on that cases. So find view by ID and then do that with the, and lot of heaviness on this kind of activities on that cases, or a fragment. So that means we can use data binding techniques there, we can use the models there, we can use the view models there, and we can use the live data. So that means these things or these approaches make your project easy and good productivity. But in some cases, whenever we have a lot of big data, we deal with that kind of data. On that cases, if your architecture be good, but asynchronous calls sometimes make it a lot of load on your project, or sometimes it gives the memory leaks on some cases. But we can reduce it as we have worked with your RX Java new technologies be there. I already described how we can use the main task and how we can use the other task with the separate combinations. But moreover, if we make it more good, because of sometimes there be the drawbacks with the RX Java that we'll discuss in the sessions, in coming sessions also. But not we can say that not exactly the drawback, but use of RX Java. That means if you use it with the smoothly, you can handle it that smoothly, or a good approach or a good way. So that means you can work with that's also be good. But instead of using that, we have a good functionality be here for the coroutines. You can implement it and make your asynchronous call good, and you can enhance your productivity of the project. So that means that is a very good approach whenever you work with coroutines. So I'm discussing about the features. So coroutine is our recommended solutions for asynchronous programming on Android. Nowadays it becomes popular, and it is a lightweight. You can run many coroutines in a single thread due to support of suspensions, which doesn't block the thread where the coroutines is running. So if you just say that a threading concepts in Java, so same thing, the work within a Kotlin, same approaches be going on, but how we can handle that data with your main program, that is the important thing. So here you can see that there a word that is called suspending, and by that we work with the suspended here. So the suspending saves memory over blocking while supporting many concurrent operations. That is the most important line. That is, whenever you work with your asynchronous calls, or there will be the lot of running tasks, and you can use many coroutines with your functionality that help each other on that cases, and suspending saves memory over blocking while supporting many concurrent operations. So that means your app not hang on that cases. And fewer memory leaks. Use structured concurrency to run operations within a scope. And build and cancellation support. Cancellation is propagated automatically through the running coroutines hierarchy, and Jetpack integrations. Many Jetpack libraries include extensions that provide full coroutine supports. So some libraries also provide their own coroutine scope that you can use the structured concurrencies. So this is important. That's important work with whenever you work your coroutines, and how we can work with your Kotlin and how you can use that. Means it is a language provides only minimal low level APIs in the standard libraries to enable various other libraries and utilize coroutines. So unlike many other languages with the similar capabilities, async and await are not a keywords in a Kotlin. Async or await. If you discuss, that means in other programming language we can use that in most of the asynchronous processes. But here Kotlin's concept of the suspending functions provide the safer and less error prone abstraction. So that is Kotlin is why Kotlin is good. That is another way we can say that Kotlin is good on this area. So the Kotlin X coroutines is a rich libraries for coroutines developed by JetBrains. That is important, and it is also been important during the interview time. It contains a number of high-level coroutines enabled primitives that this guide covers, including launch, async, and others. And we can say the coroutine is an instance of suspendable computation. It is a conceptually similar to the thread, and in the sense that it takes a block of code of the runs that works concurrently the rest of the code, as we discussed before. That means the basic functionality or a basic thing whenever you work with your any async programming, we can say the threading. Threading means threading concept whenever we work with main programs, any task with the main programs, that's be the concept of the threading. Multiple process be going on that cases, but how we can tackle it so that our program not hang on that case, and how we can implement. So that is the reason behind the work on that area. Okay, so it may be suspended as execution in one thread and resume in another one. So coroutines can be thought of as lightweight threads, but there is a number of important differences that makes their real life uses very different from threads. So we'll discuss more about that. So we can say that asynchronous or a non-blocking programming is an important part of the development landscape. So that is another definition, and I explain it in a brief. And we can say that whenever creating a server-side desktop or a mobile application, it is important to provide an experience that is not only fluid from the user's perspective but also the scalable when needed. So that Kotlin resolves this problem in a flexible way by providing the coroutine supports at the language level and delegating most of the functionality to the library. So that means we can say we have many definitions of the coroutine, which is we can you can understand easily. I explain all the ways you can just put it in your mind, and how we can use it, how we can implement it, we'll see that. So the definition is it's so easy. Okay. So here, if we go for the dependencies, use these dependencies or new versions of that. Here we have JetBrains, Kotlin, X, Coroutines, Android 1.3.9 version, and there's more about that. And whenever you work with your example of that function of the launching, I don't explain at this time, but I will do it later on practically. I will explain that. So here, just I explaining the launch part. So the launch is a coroutine builder. It means whenever you work with this kind of programming, you can see that there is a launch. So what is the launch exactly? I will explain you. Just read it, or this is a small theory part. You just put it in your mind, because of when I will do the practical, so it is easy to understand for you. What is that exactly? So launch is a coroutine builder. It launches a new coroutine concurrently with the rest of the code, and which coroutines to works independently. That means whenever you can say the launch means your coroutine launch, and it will start the work, and whenever it will start the work, that means it works separately, that is as an asynchronous. So that means it never work with your main functionality. It just work as a background way. So delay is a special suspending function. It suspended the coroutine for the specific time. So in how much time you want to go for the delay, you can use it. Just same as we work with the threading concepts. So the suspending coroutine does not block the underlying thread, but allow other coroutines to run and use the underlying thread of their codes. So that means if it work with a first coroutine and there another process be going on, so that means you can delay that and the work on the second. So it means in your programs you can make them, how you can use it or how you can implement in easy approaches. So that's the way, but it use it with a special suspending function. So it suspend the coroutine for the specific time, that is called the delay. And the run blocking is also with the coroutine builder that bridges the non-coroutines words of the regular function main and the code with the coroutines inside the run blocking curly braces. This is highlighted in the IDE by this. So the coroutine scope hint right after the run blocking opening curly braces whenever you work with this. That means run blocking and their curly brackets you have to work. So a lot of things we have to use it. And the coroutines follow the principle of the structure concurrencies, which means the new coroutines can be only launched in a specific coroutine scope which delimits the lifetime of the coroutine. And as I describe you, but on the practically first we go for that and then see the example on that how we can use the run blocking on that case. Okay. Here if you say that this is the main function and there's the run blocking, and we can launch any function, and that functionality we can do with the delay. That's very easy way or easy approach. You work with your suspending function here. So here you can see the word suspend. That means we can use that suspend function on over there. So this is the basic and most important thing whenever you work with your coroutine. And a lot of stuffs be there, how we can use the function and how we can implement it. So in addition to coroutine scope provides a different type of builders. It's possible to declare your own scope using the coroutine builders, and it create a coroutine scope and does not complete until all launch children's complete. Okay, and run blocking and the coroutine scope builders may look similar because they both wait for their body and its children's to complete. So that means they have to complete their all parts. So the main difference is that run blocking method blocks the current thread, and for the wait and while the coroutine scope just suspended. So that's the way the different approaches you can implement. So according the program requirement, you can use that. So here we have a work with the suspend first. So I will explain you how we can use the run blocking and as well as suspend functionalities both. And that's the launch. This is a run blocking. So the most important thing is as we discussed before, but I don't want to go at this time. We'll explain it later once we do the practical, which is the more useful, the RX Java of this. So we back to this, but first we go for the other pages. So yeah, these all be the differences between cancellations and lot of stuffs. So okay, now we discuss about the callbacks first, then we go for the differences of the RX Java and coroutines. So that's an important term after your asynchronous task, as we discuss. Under that we have a callbacks also. So the callbacks are a great patterns, however they have a few drawbacks. Code that heavily use callbacks can become hard to read and harder to reason about. Actually, I am explaining these small stuffs under the coroutine and become a part of that because of in our next session, that is called a new app architecture or the layers. That's very useful, and you can see that how we can implement it there. So the callbacks also be the useful. The callbacks are the great pattern. However, they have a few drawbacks, and that have a heavily used callbacks can become hard to read and harder to reason about. In addition, callbacks don't allow to use the some language features, and the Kotlin routines let you convert the callback based code of sequential code. The code written sequentially is typically easier to read and can even use a language feature such as the exceptions. So in the end, they do the exact same thing, wait until a result is available for a long running task. So the keyword suspend is Kotlin's way to marking a function or a function time available to the coroutines. And whenever coroutine calls a function, mark suspend instead of blocking until the function returns like a normal function. Okay, so that is suspend. So the suspend execution until the result is ready. That is important part. Whenever you use the suspend, as we discuss, suspend is, it means it suspends execution until the result is ready. Then it resumes where to left off with the result. Okay, so I will describe you what's the meaning of that exactly of this. So whenever you get any network request, you can say that suspend function, and then that is the use of that area. Okay, so if you say that compared to the callback based code, coroutines code accomplish the same result of unblocking the current thread with the less code. So that means whatever you work on your front end and whatever be the going on, it's we give the sequential style to it. So due to its sequential style, it's easy to change several long running tasks without creating multiple callbacks. So as we discussed what is the callback and how we can implement it, so that's same. And for example, if you say that we have a code and there's a lot of results, we can fetch it from the two networks endpoints and save it to the database. Means two different networks we can fetch the data and putting in our database. So on that case, we have to be written as a function in coroutines with no callbacks. Okay, so that means like here you can say that suspend your function whatever be the request, and you can fetch it either that is slow or fast network. You just put it on the database dot save, that's your slow, and the another or whatever be. So that's you can go with this. So there is no blocking, it's for giving a simple regular functionality. It works, and I will describe you how you can do that. So here the best part is whenever you work with your coroutines, you can work with as a room and retrofit. So how you can implement that, I will give you the example practically first, and how you can use that flow and what the use of the suspended functions be there. But you have to put it in your mind that the suspended functions always be supports that requires the retrofit 2.6.0 or a higher. Okay, so here simple examples of the retrofit will describe later when we do the practical. I explain that, and here we can work like that. Okay, so now let's discuss about the flow, and in a flow we can implement it like that. In a general coroutines, a flow is a type that can emit a multiple values sequentially, and opposed to suspend function, as we discussed what be the suspend function and how we can use the sequential functioning on that. So that returns only a single value. So for examples, you can use a flow of receive live data from the database or from retrofit, whatever be from the network. So flows are built on the top of the coroutines and can provide a multiple values. So how you can use it, we shall will discuss it. So a flow is conceptually a stream of a data that can be computed asynchronously. That is the most important. It's just like with the RX Java as we did it, and the emitted values must be of the same type. So that means if you say that if it is integer type, so integer type, string type, so whatever you type you can put it and get the result on that cases. And flow and suspended function means in the Kotlin coroutines, a flow is a type that can emit a multiple values. So as opposed to suspend functions that return just only a single value, as we discussed. So in instance you can use a flow of receive live updates. So that means we have a suspend function load data, just like we can say that if you have a load data and we can fetch. So that means how the load data returns, we update that UI with its results. Therefore this is one of the short call. This is called your one shot call in a single line, as we have done with the view models from the database, and you can show it on the UI. So you call a suspend function, you obtain the result back, but the flow is different approach practically. What is that? So flow is built on the top of the Kotlin coroutines, and besides, as a flow can emit multiple values sequentially, it is a conceptually a stream of data, so whose values can be computed asynchronously. That is the most important line. We can say that it is conceptually a stream of data whose values can be computed asynchronously. So the emitted values have to be the same type. In the below examples, we have the function that returns a flow of data type, and the means flow is able to emit the data objects in that. And if you say the data streams flow data, so another point is that to trigger the flow we can call collect the suspend function. So it requires to be called from the coroutine. In the lambda we mark what to do when we receive an element from the flow, and when a new element is emitted to the flow, updated UI will be called with the new state or new value. So if we say that if you have a launch data streams and whatever be you want to update it, so we can say that there are three entities involved in this issue. So the producer produced data that added to the stream, and flow can produce data asynchronously, and the consumer consumes the value from the stream. What is that? As we have discussed in the RX Java, the how we can use that with the main function and IO, that's all be working behind. So here we can put it in the three important and three major points in it. Number one is your producer, number two is your asynchronous data, and number three is just consumer. So the producer data that added to the stream, in addition flow can produce data asynchronously. The consumer consume the values from the streams that I will describe you practically. As you observed in the previous examples, just like I'm giving, I showed you this is updated UI with the stream. So that means that can be intermediaries which can modify each values emitted into the streams of the stream itself. So an intermediary can be able to change the type of emitted elements. Okay, so just like we can say that in Android, a data source of repository generally a producer of UI, which has the view model and as the consumer otherwise. The view layer is produces the user input events or show that on that cases. So here you can say that is the consumer, media is your intermediary, that's flow work, and producer. So here we have a UI, then we have a view models and other things, and then repositories are So that's we can use this like that. So I use that some site, I checked that this kind of image be given. So also you can go with your main site of the Android. There also be they explain it very well of the flow on your Android tutorials for the programmers. So basically the builder functions flow create a new flow where you can manually emit new values into the stream of data using the emit function, for example. So an Android app that fetches the latest news periodically. In the case news remote data source has their property latest news that returns a flow of list. Just if you say that if it is the articles, students, whatever be that, you can put it. So because of a single suspend function cannot return multiple consecutive flows, so the data source requires to create a return of flow in order to fulfill the requirement. Okay, so that's a very simple suspended function with your flow we have to work with. So here with the simple examples, here we have got news that emit with the delay, and then suspend functions we can use for the list and then fetch it from. Okay, so if you say that we have many ways to work with asynchronous data flow. So as we have done very old approaches in the previous times, that's not working on, but nowadays we are working with the Kotlin flow. That's we have a flow, we have a live data, and we have a RX Java. So for the RX Java, I already described the complete session on that. There'll be the 10 to 15 tutorials or sessions related to the RX Java with the retrofits and many things you can handle on, and all kind of observations be there, and how we can use that RX Java in a Java as well as in the Kotlin RX Kotlin session be there. So many stuffs, and in the future we'll upload more on that. But as live data we have done on my sessions in MVVM approaches, so that's the second approach we can work with the live data also. And the last is third approach, that is called your Kotlin flow. So first we have to understand that, and we use that flow in our clean architecture. So you can use any live data or RX Java, but as we are working with the flow, so I will describe you in coming sessions also with the flow. So if we go for the live data, it is a simple observable data holder, and it is best used to store UI state such as item list, and it's easy way to learn and work with, and you can just say that mutable live data and get access and then use that. But not such a powerful whenever you work with your asynchronous task. So RX Java is also be the powerful tool for reactive streams. It has many features, and we have a transformation operations be there, lot of things be there. And the last is your flow. So flow falls somewhere in between live data and RX Java. It is very powerful but also very easy to use. So how we can use that, so we'll discuss it. Okay, so we also discussed today that how we can use that flow with the room. So I will give you the example on that. First we have to go on the back where we left that flow, and that is how we can make a difference between your RX Java and your flow. Okay, so that is the important things we have to discuss, and how we can use these coroutines on that, key differences and other things. That's be the important part. So as we have done with, so either we can use RX Java or this is a concept in everybody mind that in our project. So according to the project, whatever you choose, you choose with a smart mind, and you can use that according to your app. So there'll be the lot of asynchronous task, and you can handle the your memory leaks easily. So that's you can go for the RX Java sessions. But if you do not want to go with that, you just say that yeah, it's good, and not so much complex architecture, and there will be a lot of data, but you can just use the sequential flow with your this flow. So RX Java streams are prone to leak sometimes, where the streams continue the process items even when you no longer care. So the most important thing is you have to tackle that RX Java in a very well manner. So the Kotlin coroutines use structures concurrency, so which makes it much easier to manage the life cycle. So it's as I described you that we have to avoid the leaks with there and how we can use that. And if you go for the more points, the back pressures happens when the source of the streams emit items faster than the downstreams can consume them. It is a nasty problem in RX Java and the source of a lot of complications. And it's a code base because downstreams consumer are constantly having a collaborate with the upstream produce. Okay. So if you go for the performance, Flow has it at least a good performance than RX Java. Because of that we can use it if you never be taken it according to the memory leaks and other situations arise on your program. So React Scrabble is use a benchmark tool for the streaming comparisons. The Kotlin has a version of the benchmark in their repositories. So by the metrics, the lower score is a better. So that means Flow output streams RX Java in both standard and optimized setups. So you can go with that, but as I told you that you have to choose smartly because of sometimes RX Java also be easy and carry it handle, but as discussed that for avoiding a memory leak, that is the most important. You have to handle with care that RX Java. So the main point is have to learn to use new technologies and you will have to figure out new patterns and best practice. So I want to describe you today that how we can use these new technologies in your programs. And time to time I update you or making the small sessions for you how we can use such a new technologies in your projects and how we can make your app be a good giving output and performance wise be good. So RX Java, as we discussed, there is a library, there is a RX React extensions there. So we have discussed a complete session on that I already described in this. That is, it is a generic, well documented API. A lot of stuff with here. So a coroutine is what? The coroutines, unlike RX Java, focus on offering a mechanism to write a asynchronous code. So just it always be work with the asynchronous. So as you discuss, as you see that if you started your career in your Android and you can use that async task whenever there is no RX Java and this kind of more output your memory leaks be happen on that cases, so that we can tackle with that class. But here if we give the emphasis particular on that, so on a Kotlin they give complete emphasis on the only for the asynchronous task. So that is, if we go with that, so we can use this especially for the asynchronous code. And it allowing the omissions of the callbacks in the code, which translates to more compact code that is easy to generate and refactor. And Kotlin coroutines are still experimental, meaning they may undergo changes through the hands of the Kotlin creators. Means it is not at this time not perfectly built. It also be need some updates in the futures maybe. So as it's just we have go for the implementation with that. If there is some issue be minor issues be going on, we can create the more updates on. So that means it is currently available and we start the work on it because of it is under the new technology. So they already present a stable features, providing a compact way to solve the most common problems when working with the asynchronous software, which is not an easy task because of sometimes we need the data from multi servers. Sometimes you have to take a lot of data, sometimes we need a complete streams, so that's on that cases we can use that. So the Kotlin and the coroutines are a way to write a cleaner code, and they are quite intuitive for a programmers already familiar with the OOPS. So the concurrency, multi-threading, asynchronous task, if you know well, so you can use that. So our coroutines are written using the standard Kotlin. This is library suitable for the Android projects since Google announced Kotlin as the new language for the Android. So coroutines with working with, but at this time everybody want to work with this because of as it is in a boom. So Google has already added a strong documentation support for the Kotlin and its Android API. So when it comes to the coroutines, they provide an easy way to manage the threading and are perfectly suitable for the process executions on the background threads whenever we need it. So these paradigms also provide an easy implementation of the concurrency in its structures, concurrency and easy scalable and maintainable, which makes production cycle and efficiency of the programmer. So the coroutines can significantly improve the code performance as in RX Java. So there is the ability to use is it as a stream. And on the other hand, this language's coroutines are, we can say that it is not entirely perfect. So they are not yet fully adopted by the communities. So Kotlin and coroutine are easy to write and the code is really but you can go for the startup and you work on that. So RX Java, I already described the many things. You go for my sessions on there, you can work on that. So we can implement the clean architecture with any approaches. So according to your choice, it is difficult choice and also hard to compare them because Kotlin coroutines are a thin language feature while the RX Java is very pretty heavy library with a quite large variety of ready to use operators. So because of sometimes we need to choose that RX Java because where we have a multi options, because of there is a small options we working on your coroutines. There is just a special task whenever we use the asynchronous, and that asynchronous task, if you do want to go for without any memory leakage, you just choose that. But if you want to go for your observer and as I described, you already subscribed on and main threads we working on, so you can go for the RX Java. Okay. So both are designed to solve the same problem as synchronous programming. However, their approach to they're quite different. So after all the overview, coroutine and RX Java, one might ask which is solution is the best one. So RX Java is a bigger and really powerful than a solution based Excalibur coroutines. And this difference can be eliminated by using the ProGuard and its code optimization. So we can say that coroutines are currently experimental, but you have to start, and for the synchronous tasks and other things you can use it easily. And there will be the special term that I will discuss in coming sessions, how we can use the cancelling coroutine executions when it's working. So a lot of things be there once it launched and how we can cancel it. So these all we have to work, but one by one we have to go for this. So first we go for the small examples. Then we choose a coroutine with your room and how we can use the flow with your room and coroutine with your room. So that's first I've described you. Then we work with the retrofit also, and my coming sessions will discuss the same sequence with the flow with the app clean architectures where the data layers be working. Okay, so let's discuss about it in a practical session. So here first you go with the implementation, that is the most important. You can use the org JetBrains, Kotlin X, coroutines, Android 1.4.1. So that is the most important whenever you work, when you start the work on the coroutines. As we are working with the RX Java, so we can need this implementation for the RX Java, but here we are working with the coroutines, so the same. So as we discussed that it's used for the asynchronous task and how we can implement, that's all we can do that. So first we have to understand the things be here, how can we can implement the things. So first if we go for the sequence, and we can see that what's the sequence be going on, as we have done our previous whatever we did in Java or other. So we use the threading concepts on that. So here if we go with any function, I'm making the function here, and that function be like fun, and we can say that it is a sequence example. Better we can understand the small things so we can do the big things. So that's the concepts always we have to put in mind. So here we say this is a sequence, and here the sequence be integer kind. But don't do like that function. We need to work it is as a sequence. So if you go with the sequence, yeah, this is, so that means the sequence B, we have to work under that sequence, and you can say that for and I in I dot dot for, and say we have to go for a thread and dot slip. This is the old approach, we don't go with that, but just I'm showing the example, so just work on this. So here I want to work with the yield, and that means it showed the next value whatever we go on. Okay, so that is, and once it's done, you can see that here it showed to you that use the suspend function call, because of it's not be the good, the work with the sequences be like this. So it blocked the main programs or CPU execution sometimes. So what happened, how we can call that, you can just say the sequence example dot for each, and here under the for each value I am using the println, and those println we can say that just for recognize the values, and then say value. So what happened, because of if we go for the trash hello, so it show to you the whatever be the value on that going on. So let's see what be the result of this and how it works. And I'm using the real device, but we just check the answer be here, so we can check the sequences, how the sequence be work. But what happened, that it happened the CPU consuming blocking code here. So how we can use that, we can use the suspended. So let's see how we can work with the suspended and other examples. So first we check the result of this. Okay, so you can see that here we have a hello 1, hello 2, hello 3 and hello 4. This kind of sequences we are working with, but it means that is it hangs CPU consuming blocking code, we can say that. So it showed to you, and here it remind you that you can use the suspend function call be there. So yield is for the next line, that is you can do, and yeah. So now we can hide it, and let's check how we can use that function with the coroutines. So for your coroutines function, what you need it, you need to call it a suspend form. So for the suspending calling, we can use the suspend function, and here you can say that call me, and here we have a coroutine scope. So under that scope, as we did it on the theory part, you can launch on. So first you have to launch. So it's good whenever you work with a simple theory, you can just put it in and remind it that whether we can use the launch and where be the delay. Okay, and here these small stuffs make good programming once you learn that small stuff. So I just believe in that you have to make your programming strong with such a small things. Okay, so here you can say that delay, and you can just put it on the delay, and you can say that 1000. Okay, and this on milliseconds, it works. And here inside that I am showing that this is the log.d, so we can check it. Be here it is a hello inside, or you can say that simple hello, and here it means hello inside. Okay, and here you can just check it how it works with the outside. So I'm using that work outside, so you can say that hello outside. So we can just check it how it calls on. So this is a simple function, and how you can do that suspend calling. So you have to call one more function, that is called coroutine. and this call coroutine, you can say that this is your run blocking. So that means that is a coroutine scope with the run blocking, as we have discussed what be the run blocking, how we can use that. So you can see that this is a hello, and here you can just set hello run, and here you can just call that coroutine on your main. So this is the way you can work with your coroutines. So just see and check it what be the answer for this. We clear the locket first and terminate whatever be. So you can see that hello run. So it's showing to you that it calls be here, but how you can use that call me. So here you have to call me, okay, and here it is a suspended, so we can run that suspended be here. We can check it how it calls. So under that run blocking, you can call that, and it show to you that hello outside, inside, and then run. So that's a simple steps you can work with. So here first it call that whatever be the call me coroutine scope, that is your outside scope. Then it delay, after a delay it call to you the inside, and both functions be with the block run. So that is called here this is called your hello run. So that's the way it can process. You just practice on, and if you want to go for the repetitions, and I want to repeat that function 2 times, so what to do? You just go for a suspended function, and here we have a very good thing that if you want to call it with the repeat, so you can say I want to repeat it 2 times and just call it be here, okay. So that means how it works. So just clear the logout, the locket, and then run this. How the repeat be working? So repeat always be on outside scope, and inside you have to work with the launch. So you can see that outside, inside, inside. So but to run, it works on the single time. So 2 time it works for the launching, and that is asynchronous as in a separate way, okay. So that's the way you can work with your coroutines also. And now what happened that if you're working with the list, like if we have a call list, and list is your 1 2 3 4 5, and you want to delay on that list, and how it works with that. So for this just remove that or the clear the locket, and you also clear your call routines, and I'm making the new function that is called here list form. So this is an example of the coroutine scope, and here I'm giving the list of coroutines. So here you can just work your suspended function, and you can say that call list, and under that call list you have to go for the list, and the list I want to use that as an integer type. If you want to go for other data types, you can call it, because of from the retrofit call we can use the models here. So you can use that models and from the backend, and I'm using the 2000 here on that milliseconds, and on this is the delay, and you can just set the log to, and just for your hello, and then on the message I can say that hello call. So we can check that suspended be working, and here I'm using the return function, and return be a list of this is the list of 1 comma 2 comma 3 comma 4 comma 5 comma 6, okay. So once it's done, that is the return list, and here I'm using that call, I'll set it's called call list, and here the same thing, I'm working with the run blocking, and that under the run blocking what to do, you just call that list. So you can say that call list, and that call list is for each, and I'm using that for each within the curly brackets, and here we are working with the same as our lambda, as I described you on my last session, where with the rules of lambda. And here you can just say hello plus value, so you can just check it that what be the scope of that run blocking. Okay, so that's the way you can work on with your call L. So here I'm using that call L. Okay, and let's see how it runs behind the scene. So terminate that first, and you can say that here it show to you 1 2 3 4 5 6. So here it is a call. So this is called your list returning. So simple, this is a simple list returning. You have to go for your run blockings with the delay. So that's very easy to work with suspended functions. I'm giving the flow example, but on my next video I will describe you that how that flow work with the room. So that is the important part, and how the use of the view model on that cases. But for the simple, you can do that fun flow example, and whenever you work with that flow example, you can say that flow, and that is your int, and on that int I'm using that flow, and that flow, under that flow we have a 4, and you can say that I in 1 dot dot 4, and under that 4 you can just go for the delay, whatever you want the delay, 1000 on the background, and here the thing you can use it, that is called your emit, and that emit is I. So here we work with, as you can get the data from the backend, you use the model here, whatever be your count you can use that. Here you can use the delay, and whatever you want to print on the backend, or you can get the data, is called your emit. So these are simple flow examples you can work, but I will explain these things more in my second session, that's come for the room, and how we can this flow we work with the room. That is the main part of, and that is a bigger practical, and that is a big section on that. I mean a long time we can spend on that. So just practice on this small steps, so we can go for the clean architectures with the flow. We can use that in our also the room with flow, retro with flow. So a lot of stuffs we can use that. So as we have discussed with examples of the flow, and we work with like this, what is the flow, and what is the coroutine functionalities be here. So we'll discuss later how we can use in my coming session, that how we can implement that flow with your room, and how we can use that. So here simply we can work with the flow like in the consumer, intermediary, and your producers, as we discussed, and how we can implement. So whenever you work with your net news API or other APIs, whenever you call that, you can just work with, as we have done, whatever be the value we can emit and we can delay. So these things you can work with. This is your flow, whatever be the model, whatever be your value, and whatever you want to emit and want to delay it. So these all be the simple examples on that. So in my coming sessions we'll describe you the more things about that, the flow, and how we can implement with the room. So we have to discuss these all stuffs in my coming sessions. So room with flow we shall discuss it, and we learn the practically how we can implement this kind of stuffs. So now let's see some example of your how we can what is the difference between your RX Java and the coroutines first. Little discussion on that. So as we have learned that today with the coroutines, and I explained the things with the theoretical and the practical manner, both the ways. And here we have done some examples how we can you do the launch and how we can use these suspended functions. So simple, a very easy uh, working with the your coroutines we have done, and also we have discussed the flow, but lot of things in a flow in the future, and what's the difference between rx java and these all. And also we have done with the callbacks, will describe you in my coming sessions more about that, and how we can use that. You can see that as we have done with the simple examples of the suspended function, so you can fetch your data from the retrofit calls also will describe you. But we have to do first a basic example on that, that is called your simple room and flow. That is a most important part, so in my coming session I will describe you these things. Okay, so thank you so much for the day, and we'll discuss it with the practical, and that is also be the long session on that. So we have to work on that, so how we can use this, so practical manner how we can use that implementations on in your Kotlin. So we'll discuss about that, and the sequence of the third session be that we have to work with a clean app architectures also. So we discuss the new features of the Kotlin, so let's just practice on that. And thank you so much, and thanks for your lovely comments, and whatever you want will explain it in my coming sessions. So thanks a lot.